So here we are, and as usual, before we even really get started, we need to save our file so we can set up all the variables and whatnot. So here we go. I have like a Rigids 3 thing here, and I like to have scenes. We're going to store our sim cache here, maybe some intermediary like other kind of caches here, and then the actual helicopter file is in here in the ABC area. But at any rate, so I'm just going to put it in, let's say, some project area slash scenes. You can do whatever you want, of course, but just so you know, that's what I'm doing. And then you want to go to aliases and variables, and you'll see that automatically the HIP file is set to where you saved it. And I like to say that the job, because this is the variable I'm going to use a lot for in other paths, I want it to be that Rigids 3 thing here. So there we go. And now it's set, and if you don't believe me, you can go back and see. There it is. Cool. So now whenever I say $job, of course, it's going to point to that. Okay. All right, so let's go over here, and we'll say tab, type geometry, and let's drop down a geometry node here. We're going to call it frac, because this is where we're going to do all of the fracturing of the helicopter. That's what we need to do first, is bring in the helicopter and break it up. So there it is, frac. Now we're not going to read in a native Houdini file, so we can't use the file sub for this. We're going to bring in an Alembic. The helicopter that I made in Maya has been exported to a cross-platform format called Alembic. Now, I suggest that you put it in your job/ABC area. Obviously, you can put it wherever you want, but either way, it's this one, the one that's included with the lesson. We just select it, and there it is. Beautiful. So we can just call it something like import heli. Now we don't need it to read it on every frame. So if I resolve this here, you can see it's trying to, if this was an animation, this would make sense. In our case, it's not. So let's just not even have it waste its time trying to do that. So I deleted it by going to delete channels. Great. So what do we have? We have 395 packed alembics, which basically means that if I go into this, which is just S to select, these are the pieces. There's 395 of these pieces, which were essentially the pieces that they were in Maya when I made it. Now you could select these pieces by names. Right now, it's just selecting them by the fact that each one is a packed alembic. A better way is when we go into this mode, and we can press 9 to go into this mode, by the way. If you forget that, just hold the mouse over it and you'll see it says 9 there. I'm going to make this bigger. And then instead of it looking for groups, let's have it look for alembic paths. Aha! Now we essentially see the way it would look in Maya or a similar program. We've got kind of a hierarchy here, the top of it, the body, chairs, whatever. There's quite a bit going on here. So you can either select it in here or you can select it out here. I don't want it to assign its own colors to it right now. I'm just going to turn that off by clicking this. As you can see, this guy, color groups and viewport. So by selecting one of these things, we're selecting it by the path. The path is an attribute. If I middle click here, one primitive attribute, path. We can look at that here. Here is the primitive string attribute path. And there they are. Each one stores its hierarchy. Like so. So they all have a unique name coming out of Maya, and we can select them based on those things. Which is great, because in case we ever need to change something in Maya or your model or on your project or whatever, changes, let's say, the shape of this window or something, as long as it's the same name, which in this case was windshield, window L, glass A, any operations we do based on that name, it will still find it again. So suffice to say, when we're selecting, make sure that we're selecting by alembic paths, which is just populating the path thing here. Awesome. So with that in mind, and we don't need to have this open all the time, we could still, just bring it back whenever we want by pressing 9, like so. Awesome. Now, one kind of annoying thing about this being made in Maya is everything has this kind of shape text thing where the name of the object might be cockpit floor C metal C1, and you'll see that it says cockpit floor C metal C1 slash cockpit floor C metal C shape 1. So what we're going to need to do is chop off that last thing. So whatever is after the rightmost backslash needs to be removed. Or looked at another way, you can see here, door 4, window R glass A. It's just repeated here again, underscore shape. That's just because that's the way Maya works. That's not going to help us here, and we're actually going to want to get rid of that now so that we can export it back into Maya. You'll see how that works later. You may not even need to export to Maya later, in which case you can skip this entirely. But just people have asked before about how to get things in and out of Houdini, and it is tricky with rigids. So I'd say do this anyway, just in case you ever do want to export this to another package. So again, all we want is the original hierarchy body slash the front door slash this particular hinge piece, and we don't need the redundant thing here. You'll also notice while we're talking about it that each of the pieces says glass A, metal B, metal A, and so on. This is a good idea for the modeler on your team, whether it's you or somebody else, to do. It'll make applying materials to this much easier later, because the modeler will usually know, like, well, this is a glass window, or this is a metal this, or whatever that. It just helps keep things organized. So we basically just have the name of the piece, where it is, and what kind of physical property it is. You don't have to do it this way again, but a lot of this lesson is about workflow, which will make tackling these complex tests easier by having a very good workflow. So just so you know, that's why these things are called this way. Later on, we can assign either physical properties like brittleness if it has glass in the name, or maybe we'll assign an actual shader to it because it has glass in the name. For now, let's proceed with lopping off everything from this last backslash on. I like to use Python actually for this. We talk a lot about Vex, and we'll continue to talk about Vex for basically the remainder of this lesson. But we'll say adjust paths. Python is much more robust in terms of dealing with strings, and we don't need this to like run fast or anything. So we might as well just use a Python thing here because it's easier to understand. And again, it just has more tools for dealing with strings. So what are we going to do here? The node, and this we get for free, node will refer to our current node. This means print working directory, which is like a shell kind of thing. But all you need to know is it's going to return the node itself. Geo is going to be this node's geometry, which of course is what we want to work on. That's why it's included standard, because this is usually what you want. So we're going to say, and for more information about Python, consult your local library, but for now, just follow along with this. For every primitive in our node, we'll do something. And all we need to do is say, get that path that we were just talking about. And the way we do that is say, the primitive has an attribute. Every primitive here has this path attribute. So prim.attribute value path, that returns the path that we just saw. Let's change it. Let's say the new path is going to essentially be the path, and we're going to end this syntax means, because there's nothing to the left of this colon, that means everything from the beginning until this. So if I said this, and then I say prim.set attribute value. So we just read the path attribute value, and now we're going to set it. And we're going to set that same path one, and we're going to set it to that. And that's it. So now you'll see it just has the first 5 characters. So if I did this, that's the first 10 characters. Now, of course, how far we want to go with this is going to vary. In our case, we want to go to just wherever there is the first, or rather the last backslash. And so a kind of a convenient way we can do that is say, start from the beginning, because that's the left of the colon, and go to Just find it. What is rfind means find from the right. Find that last backslash, and that will be the index of where we want to go to. And there you go. So now you can see this is what it was. This is what it is. I lopped it off, nice and clean. To reiterate, this won't have any effect on your simulation whatsoever. You don't need to do any of this if you don't intend on exporting to Maya later or to some other package. But again, you might as well do it because, you never know. So there you go.